Hi everyone, my name is Rani. I'm studying at Institute of Aeronautical Engineering. Today I'm going to give presentation on meta learning to improve unsupervised intrusion detection in cyber physical systems. Cyber physical systems are nothing but Internet of Things devices, such as the best example would be the self-driving cars uh, self-driving cars and smart healthcare devices such as sensors and other devices used to detect any health issues in the health of a person. So let's see how the meta learning would help to detect the intrusion in cyber physical systems. So let's understand the introduction to the cyber-physical systems, and then let's see the process of the how to make it to better improvise it from this traditional technologies used in detection of cyber-physical systems intrusion. So cyber-physical systems combine advanced computing networking and physical components to create powerful interconnected systems. Unsupervised intrusion detection is a crucial technique for securing those complex CPS environments from malicious attacks and unauthorized access. So nowadays, the technology is rapidly increasing, and the usage of AI is more, and everywhere there will be the usage of AI nowadays. And to 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 reduce the attacks, to reduce the malicious attacks or from unauthorized access, we need to give a better algorithm, or we need to choose the better technique to protect from the any malicious attacks. So for that, we need to have the detailed information how to detect the intrusion detection, and what are the complex algorithms we can use, and what are the new techniques we can use to detect the intrusion. Let's understand in this PPT. So limitations of traditional intrusion detection approaches. Let's before going to introduce the new technologies intrusion detection, let's understand what are the drawbacks of the traditional intrusion detections, and what was the thing that we want to change in the modern intrusion detection techniques. First, understand the what are the 4 points that are needs to be keep in mind to detect any intrusion detection. First, inability to adapt. Traditional intrusion detection systems often rely on predefined rules or signatures, making them inflexible and unable to adapt to evolving cyber threats. As technology is growing, there are the chances of being different kinds of actions to be done, and these are not will be given to the these are not given to the traditional intrusion detection, and they cannot able to recognize the threats. So for that, the the new modern technology would should be able to detect the intrusion where it doesn't have where it has to adapt to the new environment or new technology. And high false alarm rates. These systems frequently generate excessive positive alerts, overwhelming security analysts, and reducing the overall effectiveness of the detection process. As these traditional intrusion detections are very less accuracy, providing the less accuracy than the modern intrusion detection that we are going to use, and this would result in the false alarms. This will result in the false alarm rates, high rates of false alarm, and uh, that could rapidly decrease the effectiveness of the detection process. Limited visibility. Traditional approaches often lack a comprehensive view of cyber physical system, resulting in blind spots and an incomplete understanding of potential threats. So these limited visibility, these have the detection of intrusion up to the limit. They can't go beyond that and detect the intrusion. So that causes the new problem that cannot be avoided. So to to get that future into the modern intrusion detection, there are used some of the algorithms to detect the uh, intrusion in unlimited way, and there can be there can be adaptability to the new technology, and it is highly it doesn't give high false alarm rates, and it is the beyond of the limit. And next one is lack of context awareness. They fail to consider the specific context and operational environment of the cyber physical system, leading to suboptimal detection and increased risk of missed attacks. So these traditional intrusion detections are not that much of high featured and highly detected of or intrusions, because they are using the techniques of the traditional, so that could not detect the that could not detect the risks of the new technology that are going to increase day by day. So to overcome all of these drawbacks, we are going to understand what are the new features we are getting in the modern intrusion detection. Importance of meta learning for unsupervised intrusion detection. So what the meta learning is and how we are using it, let's understand. Unsupervised intrusion detection in cyber physical systems faces unique challenges due to the complex and evolving nature of cyber threats. As day by day there are there are new technologies coming, and there are cyber threats would also will be increasing. So there will be using meta learning. Let's see what is it. Meta learning techniques offers a promising approach to address these challenges by enabling models to adapt and learn from limited data. So these meta learning would as we see in the drawback of the traditional intrusion detection, the algorithm couldn't adapt to the new technology threats. So but here meta learning would be able to adapt and learn from the limited data. By leveraging meta learning, intrusion detection systems can more effectively identify knowable attack patterns, overcome data scarcity, and maintain performance in dynamic environments. This is crucial for protecting critical infrastructure and Internet of Things devices from emerging cyber threats. So this meta learning could also be used to data scarcity to reduce the data scarcity and maintain high performance in dynamic environments. As the technology increases, technology would change, the dynamic environments would be needed, so that the adaptability is must and should, right? So for that, the IoT devices would also should be able to adapt to the new technology and detect the cyber threats. Next, overview of meta learning techniques. Gradient based meta learning. So there are four types of techniques: gradient based meta learning, metric based meta learning, memory augmented meta learning, evolutionary meta learning. Let's see one by one. Gradient based meta learning. These methods, like model agnostic meta learning, learn to quickly adapt a model's parameters to new tasks using gradients. So these are basically used to adapt to the new technology, new to detect new cyber threats using gradients. And metric based meta learning, these approaches such as matching networks and prototypical networks learn a distance metric to enable few short learning of new classes. So basically metric based meta learning would be in the concept of networks, sending of data from one source to the another destination. So that could be a metric for metric based meta learning, and understanding what are the cyber threats in it and overcoming it. Memory augmented meta learning techniques like reinforced continual learning, RCL, leveraging external memory modules to capture task specific knowledge for rapid adaptation. So to store the memory modules of captured task specific knowledge for rapid adaptation. This memory augmented meta learning would be used to store the task which is rapidly changing, so that will be stored in the memory. Though that type of meta learning would call memory augmented meta learning. And next is evolutionary meta learning. Evolutionary algorithms like neuroevolution of augmenting topologies, that is NEAT, evolve neural network architectures and weights for meta learning. So this evolutionary meta learning would revolve around the neural networks architecture of the system and based on and weights for meta learning. Applying meta learning to unsupervised anomaly detection. Data pre-processing. So there are three types to unsupervised anomaly detection. Anomaly detection in the sense to detect any unusual thing that is done in the system or in the any devices. So basically there are three steps: data pre-processing, feature engineering, and meta model learning. So meta model learning would be the last step. First, data pre-processing. Prepare the data for meta learning. Extract relevant features for anomaly detection. Train a model to adapt to new environments. So first there would be need of data for meta learning, and what are the relevant features we need to detect the anomaly anomaly in detection, and what are the meta modeling training we could provide. To apply meta learning to unsupervised anomaly detection, we first pre-process the data and engineer relevant features. We then train a meta model that can rapidly adapt to new unseen environments and data sets. This meta model serves as the foundation for our anomaly detection, allowing systems it to generalize beyond single fixed model. So challenges in implementing meta learning for intrusion detection, there could be, as we see in the drawbacks of traditional meta learning, we could traditional intrusion detection. We also have challenges for implementing meta learning for intrusion detection. What are those? Data scarcity. Acquiring sufficient labeled data for training meta learning models can be challenging as the real world intrusion detection datasets are often scarce and imbalanced. So the real world intrusion would be the scarce and imbalance as the rapid change in the technology. Computation complexity. The iterative nature of meta learning algorithms can be computation intensive, especially when dealing with a large scale cyber physical system data. Generalization challenges. Ensuring meta learning models can generalize effectively to diverse and evolving cyber physical system environment is a key concern. Next, interoperability. Providing human interpretable explanations for meta learning based intuition detections decisions can be difficult, which is crucial for real world deployment. So let's understand what are the results and performance comparison between the traditional uh, intrusion detection and using the meta learning intrusion detection. The results show that the meta learning based approaches outperforms the traditional anomaly detection techniques in terms of overall F1 score, precision, and maintains a comparable recall rate. This demonstrates the improved ability to detect cyber threats while reducing false positivities. So this is F1 score, precision, and recall. In traditional anomaly, there are the less there are high rates of false rates, and algorithms would also cannot detect in the changing of technique. But coming to the meta learning approach, there would be the easy way of adaptability, and the false rates would also be reduced. Next, implications and future directions. Improvising resilience. The applications of meta learning techniques can help develop more robust and adaptive intrusion detection systems, improving the overall resilience of cyber physical systems against evolving threats. Automated anomaly detections. Meta learning enables the development of self-improving anomaly detection models that can continuously learn and adapt to new patterns of malicious activity, enhancing the automation and effectiveness of intrusion detection. Synergistic AI advancement. Advancements in meta-learning can drive further progress in the field of artificial intelligence, leading to more intelligent and contextual cyber defense systems that can anticipate and mitigate threats more proactively. And let's understand what are the key conclusions and key takeaways. In conclusion, the exploration of meta learning techniques has proven to be promising approach for enhancing unsupervised intrusion detection cyber physical systems. By leveraging the power of meta learning, organization can develop more adaptive and design and security solutions capable of responding to evolving threats. So mostly these 3 points are important in meta learning. What are they? Adaptability, holistic approach, and innovation. Meta learning enables intrusion detection system to adapt to new data patterns and attack vectors, ensuring continuous protection against emerging cyber threats and holistic approach. Integrating meta learning into intrusion detection strategies provides a comprehensive and interconnected solution for securing cyber physical systems innovation. The application of meta learning in this domain represents a significant step forward in the evolution of intrusion detection, paving the way for more intelligent and proactive security measures. So these are the three features we added into the meta learning to understand and adapt to the new technology for detection of cyber threats.